Hello everyone. In the last video that I have uploaded yesterday, we have studied what is actually the filtration and which are the different types of filtrations. We came across a slow sand filter, sand filtration and its advantages, its disadvantages and different limitations if we use a sand filters, and its schematic diagram and different parts, everything we have studied in the last class. Today we will move further to other type of sand filters that generally use in almost all the water treatment units. That is rapid sand filters. The meaning itself indicates rapid means fast. Sand filters, filter media used is sand. So this is the schematic diagram representation. There's a difference. There is not a huge difference between the slow sand filters and rapid sand filters, and some of the working procedures are completely different than the latter one, what actually I have explained yesterday. You can say inlet chamber. If I will explain from the left side. In inlet chamber you can see, and there is water level while filtering at the top, and at the middle you have water level while washing, and at the bottom you can see wash water troughs and sand bed, gravel bed, and lateral drain and central drains, and wash water drain you can see at the left bottom, whereas at the right you can see two types of tanks. One is a water storage tank and air compressor unit 2, and next you can see to filtered water storage tank. Once it is, the water is filtered, and at the right side you can see wash water pipe. And these are all the some general terms that we actually use, and some units that actually rapid sand filters have. So this is the another representation. There is view of rapid sand filter with the under drainage systems. You can see at the bottom there are lateral drains, and at the center you have cast iron manifold, which is a central main for draining of water from after filtration, and a filter tank you can see, and wash troughs, filter media, that is sandbed and gravel, coarse garnet and graded gravels, perforated ladders, and filter floor you can see, and wash troughs also we can see here, and I will explain later what is the actual advantage of wash troughs. So it's an enclosure tank. It's a things are like depth of tank should be around 2.5 to 3.5 meters generally, and area of filter is 10 to 80 square meters, and filter media sand layer is about 60 centimeter to 90 centimeter depth, and it should be placed over gravel, as we follow the same thing in slow sand filters too. And sand must be laid in layers, and fine should be at the top and coarser should be at the bottom. And base material usually we use as a coarse that gravels, each size of a 60 to 90 centimeter thick gravels for 5 to 6 layers, and next each layer of about 10 to 15 centimeter depth, and bottom layer gravel is 20 to 40 mm, top layer is 6 to 12 mm size, intermediate will be in between 12 to 20 mm. So under drainage system to receive and collect the filtered water, and to allow backwashing for cleaning of filters. Yes, which are the other apparatus required for rapid sand filters? That is wash water troughs to collect dirty water after cleaning. I will show you the video later. In that video you will understand very better what is actually the backwashing. Okay. Next, it may be of a square or V-shaped or semicircular or cast iron or concrete or steel structure, and spaced about 1.5 to 2.2 meter apart from one wash water trough to another water trough. Next, air compressors for 4 minutes or so, the rate of about 600 to 800 liter per minute per square meter. Air compressors, I will tell you why actually air compressors are required here later. And rate controllers, Venturi state controller, and miscellaneous access like head loss indicators, meters for measuring rate of flow, etc. So you can see working and cleaning. So rapid sand filters, for rapid sand filter, washing is one of the very important component, that is backwashing. In this diagram, you can see in the first diagram, that is operation during the filtration. However, just see the arrow mark of water, how actually it enters. Arrow marks in the both the diagrams, the difference is arrow mark. Just to see once. So in the first diagram, water supply from the top and it moves downwards, filter media, and again it goes to filtered water outside, and undrained support also it is there. And whereas in the second diagram, there is operation during cleaning, so all the arrow marks get reversed. That is, backwashing is nothing but from the bottom you have to supply the water, so that after filtration you have to clean that filter media, because during the filtration the impurities, what actually I have explained in the last video, the impurities like algae, fungi, and suspended solids, colloidal solids which are present, they will be stuck in the gap between sand filters. So once it is not cleaned, then for when you go on doing filtration process, the rate of flow after the filtration process start reducing, because of those suspended particles which are present in the present in the gaps, which are present in the gaps. So filtration rate get reduced. So backwashing is very important. In backwashing, they will reverse the flow, that is, from the bottom side, from that gravel, they will forcefully supply the water to the upper side, that is from the gravel to the coarse gravel, next it comes to the coarse sand, and fine sand at the top. So in the reverse direction they will flow the water such that all the materials which are present in the pores of the impurities which are present in the pores of the sand, they will again get collected and they will be mixed with water, and finally that water will be water is removed through water troughs, which actually can you see, you can see in the second diagram that at the top they have written back flush water out. From there the water get collected with the impurities and it is drained off. So that is actually the general idea of backwashing. So I will show the video later. Next, pressure filter. So to go for backwashing, this pressure filter plays a very important role. So you can see raw sand, gravel, and raw water inlet, filter water outlet, and backwash supply and backwash drain. So you are using some pressure just to pump the water in opposite direction from the bottom to top. You have to maintain some pressure. So pressure filters, just like small rapid gravity filters placed in a closed vessels, and raw water is pumped into vessel by pump, and pressure developed around 300 to 700 kN per meter square. And construction is classified as horizontal or vertical pressure filters. Diameter vary from 1.5 to 3 meters, and lengths and heights may be vary from 3.5 to 8 meters. So its rate of filtration is around 2 to 5 times more than the rapid gravity filters, and ranges from 6,000 to 15,000 liters per hour per square meter, and efficiency is less efficient than rapid gravity filters in removing turbidities and bacteria, and quality of effluent is poor and not suitable for public water supplies. So you can see the different angle of pressure filters. Generally they will use like top vertical pressure filter and bottom horizontal pressure filters, and the top two diagrams shows the vertical pressure filters, whereas bottom two diagrams shows the horizontal pressure filters. So during rapid sand filter, what are the different troubles that a person gets to that rapid sand filters? What are the different troubles? First one is cracking and clogging of filter bed, and formation of mud balls, air binding, sand incrustation, jetting and sand boils, and finally sand leakage. So we'll go one by one. What happens actually during the rapid sand filters? Cracking and clogging of filter bed, that is, surface clogging and cracking are usually caused by rapid accumulation of solids on the top of the filter media. Cracks are more at wall junctions. So cracking and clogging of filter bed takes place, and formation of mud balls, that is, mud balls are formed because of a conglomeration of turbidity, flock, and sand and other binders, formed because of insufficient washing of the sand grains. So if impurities are present when you apply the sand filters itself, if some impurities are present in that without knowingly, when you add it, so it will also cause some formation of mud balls. Next, air binding. So it is caused by release of dissolved gases and air from water to form bubbles. Air binding. These bubbles occupy wide space of the filter media, sand and drain system. It is caused by negative head loss, warm water and increased DO in water. So when any air binding is present, then it happens like it is caused by release of dissolved gases and air from the water from which forms bubbles. So those bubbles will come and accumulate in the spore spaces. Again, they will reduce filtration rate. Next is sand incrustation. So it occurs due to accumulation of sticky gelatinous material or crystallization of calcium carbonate, and sand grains enlarge in the size and effective size changes. Sometimes sodium hexametaphosphate can also be added to keep calcium carbonate in dissolved state. So when some calcium carbonate comes into picture, so sand grains enlarges its size, which changes the effective sizes of the filtration media. Again, it affects the rate of the filtration. Next, jetting and sand boils. So these are produced when drinking during backwashing. Water flows path of least resistance and break through the scattered points to small differences in porosity and permeability. Jetting can be avoided by surface wash or air source. Next, last one is sand leakage. That is, it results when smallest gravels are displaced during backwashing. So always when you will pressurize from the bottom, the displacement of the filter media takes place. So in the displaced during backwashing, that is, smallest gravels may be displaced, which again forms the sand at the top layer to leak to the bottom. So water will enter the under-engine system unfiltered, and in between sand and gravel, garnet layer can also be used to tackle this type of problem. Thank you. I will show the video now. Just to see here, you can see the filter bed here, which is actually rapid sand filter bed, which is actually used for filtration process. You can see at the middle there is one separator, right? That is nothing but your washer, backwashing troughs, and either sides you have the sand filters. Okay, that is filtration medium. And from the bottom, actually, it has a setup like the air pressure starts from the bottom. So it has a depth of 2.5 to 3.5 meters. So at the bottom there is a gravel, and when it comes to the top, it's a very fine sand filters. You can see, observe only the sand filters now with one washer or water wash troughs, and I will move further just to see. Can you see how actually the filtration bed has um, color? It's completely completely it is filled by impurities. Now just see, it is like boiling. Yes, you can see it's like boiling. That is nothing but from the bottom they have given the air pressure. Already water is present, they have given the air pressure, so air stress just air tries to escape from the pores, but actually during the filtration process pores are completely filled by impurities. So when you apply the pressure from the bottom side, from the bottom, it starts, the air starts coming out from the top. So when it comes from the top, again, when during its path it brings the impurities which are present throughout the filter media. So just to see, you can see it is you can feel it is actually like boiling. Okay, so when it starts uh, disturbing, that is it's like shaking the filter media completely. When it happens, all the uh, impurities which are present in the gravel or in the sand spore spaces of the sand filters, it comes to the top. Okay, you can see boiling it, and finally again it goes depends upon the impurities, and depending upon the size of the filtration, the this minutes of air pressure, the time they will specify sometimes. So it may be around 2 to 3 minutes or more. Just can you see the muddy color of water at the top? It's like all the impurities which are present in the filter media, just due to the air pressure and disturbance, it comes to the top level. Can you see it? Just to see its color. These are all the impurities which are actually present in the filter media. Just see its color once. Okay. Now, just see the air pressure from the bottom. It is just stopped now, and now it is time to lift the water, just to without disturbing any filter media. From the bottom they will supply the water, that is nothing but backwash water. Again, from the bottom they will raise the water level, just see once, so that now all the impurities came and it settles at the top, and it is completely thoroughly mixed with the water which is present at the top. This water has to be removed. So only one is, you can't supply the water from the top. Only the thing is, you have to supply the water from the bottom side. So just see it once. Very slightly they are raising the water level. They are supplying the backwash water from the downside, so it should not be get disturbed more. Just see, it comes to the top and it just flows the water carrying the impurities, and it goes to the middle row. Just can you see, it is falling to the middle row, that is actually water troughs. Okay, see the color of the water, it's completely muddy in nature, right? So just to see, water is flowing, just to see the color of the water. So from the bottom they supplied the pure water, that is nothing but your backwash water. They supplied it from the bottom, and just to see, when it supplied from the bottom, again the water level raised. First they uh, pumped the air pressure just to disturb and just to bring impurities from the bottom to the top, and then they supplied the water, so that again from the bottom, again the all the filter media starts cleaning. Just to see, you can see here. Finally I will show it. It goes to many minutes, or it may require hours together. It actually, this process require hours together. That is backwashing, it's termed as. Just check there is a change in color, water color in the filter media. You can see the pure water later. See again, it is getting purer. You can see in the both the sides, you have filter media, and just to see how actually it getting clear. Just see here again. See the color of water in the middle water troughs. So it is not like previous. It's getting clearer. I will go. I will move back once, just to see how actually it transforms from impurities to the purity. Just to see it. Again, water is coming to its original state. So that water, just see the color of this filtration filter tank. Just see its color once. Okay, similar type of color you will get here after the filtration process. Just look it once. Finally we will get, just look it.
Yes. So from the bottom, when you supply the water, from the top also you will get pure water color. So it indicates that the filter media is completely cleaned now, and it will come to, just to see, in this this is actually the process of backwashing, okay, which is used in the rapid sand filters. So thank you for this wonderful video. I will refer this guy. Okay, thank you so much.